no, sorry, well, we took researching to the next level. We've already looked at researching in nature. We had a look at researching in history. Who can tell me again, why do we look at nature when we are starting to do research? Baldy, why do we look at nature for research?
The nature can have mysterious things and special things that we don't do in real life.
That makes a lot of sense. So yeah, nature can provide us with interesting ways to solve solutions. Animals are natural engineering. They've been around for a very long time. Some of the things that they do, maybe we can copy. Maybe we can engineer them for ourselves. What do engineers look for in nature? So say they do research, say they're looking at a particular topic. What are engineers looking for? If it's a word that begins with P, it means to repeat itself. Yeah, Billy. Sorry, Billy.
It's a pattern.
Yeah, they look for a pattern.
It's a pattern.
Yeah. So engineers look for patterns. If there's a pattern, it means that there are multiple animals or multiple things doing something some way. If multiple animals are doing it and many animals are doing it, then do you know what? Maybe that works. Maybe something that they're doing is working really well, and maybe that's something that we should copy, particularly for engineering. Now, to help you just get some more understanding about this, what I want you to be sure is that the pattern they are looking for is probably about behavior, okay? So we looked at the fox and the eye with their ears that face forward. We looked at the deer and the rabbit, the ears face to the side. So there's a pattern. There's two types of way that animals' ears have naturally engineered to allow them to do something. So there's two animals, two different types of animals, completely different types of animals that live in completely different places, but their ears are designed and engineered to do the same thing. So that's the type of pattern that we would look at, okay? We also looked in the past. We looked at some very, very old hearing devices. Why do you think engineers look in the past when they are doing research for to provide a solution? Okay, Trixie, what do you think?
I think engineers look back at the past to see the older design of the past and making new improvements.
Yeah, there we go. That's the exact word I'm looking for. Good job, Trixie. The word is improvement, improve. I'm going to use YouTube as an example. YouTube's a really, really good example. So when YouTube first started, and I remember this when YouTube first started because I was working in a company. Well, I was looking to work in a company that was looking into making a lot of videos, and they didn't know what to use. And at the time, you had stuff like Vimeo, Dailymotion, you had something called Flickr, you had Pinterest was starting to come out, and all these other kind of like platforms to allow you to share videos. And YouTube was one of them. YouTube was not very good. YouTube was quite boring. There was no functionality. You couldn't skip ahead. You couldn't move. You couldn't do anything. Then what happened is Google bought YouTube. Google said, that's a really good idea. I like this. So Google bought the rights for YouTube. So what Google did then is, hold on, you now have one way of doing things. We're going to take all the things that you have done and we're going to add on them and make them better and better and better and better and better and better. So what Google did was they took the old version of YouTube and they made a new version of YouTube by looking at what YouTube had done in the past. And that's just one example of it. If you were to think about cars, okay, here's a really, really good one as well. Think about a really old car. Let's try again. What do you think the first version of, let's say, a shoe? What do you think the first version of a shoe was? Cherry, what do you think the first version of a shoe was?
How about it was made of wood?
Yeah, probably made of wood, right? So there was probably something a long, long time ago where people said, you know what? I have a problem. My problem is that every time I stand on rocks in my bare feet, it really hurts. And I don't like that. What am I going to do? Do you know what? I'm going to get a bit of wood. And I'm going to strap that wood to my foot. And with that wood, I'm going to be able to walk on rocks and not hurt my feet. Aha! Genius! Great idea. Perfect solution. But now, we have a lot of materials. We've got waterproof materials. We've got different types of shoes. We've got shoes that are extra comfy, shoes that are good for people with bad backs, shoes that you wear inside, slippers. So once again, as Cherry said, the first version of shoes was probably some wood. Over time, it got more and improved. It got better, okay? Okay, let's jump back into this, okay? So we started doing this yesterday in terms of looking at improvements of the hearing devices. I want to just finish this off because we didn't get to finish it in the class yesterday. So we're going to do that quickly, and then I'm going to talk about testing. Yesterday, we spoke about an improvement for the short ear trumpet, okay? We said that the limitations or the constraint of the short ear trumpet was it could only hear sounds close by. Now, because it can only hear sounds close by, it's constrained. It's restricted to hear anything else. We said that improvement would be make the tube longer, make it able to hear in different places so you don't have to just hear things that are close by. What's an improvement for the long tubed ear trumpet? So let's have a look at this again. We said the constraints were it's not so easy to use and can only hear certain sounds at one time. So let's take it's not so easy to use. Okay, let's take that constraint. What is a way that you could make the trumpet easy to use? What's something that you could do to make it easier to use? Pumpkin.
It's not heavy or too easy to use.
Yeah, make it light, right? Okay, so improvement would be to make it lighter and easier to move around. Good job, Pumpkin. Well done. And what about the other constraint, that it can only hear some sounds at one time? What could you do to help that ear trumpet hear more than just one sound in one place? Cherry, seeing as you are reading a book.
Bigger.
Make it bigger. Okay. We can make it bigger. As we said, that when you are looking at the long ear tube, you can make it bigger, easier to move around. You can also make the trumpet size bigger. Think about it like this. Think about when you are cupping your ears, right? If you want to make the sound longer to hear a bigger sound, you make a bigger cup around your ears. But if you want a smaller sound, you make a smaller cup around your ears. It's all about how much sound do you wish to let into your ear at any particular time. The bigger the hole is to let sound in, the more sound you're going to hear. Okay. So, stethoscope. What are some ways we can improve on the constraints of a stethoscope? So we said we can only hear things inside, can't hear things outside, and can only hear one part at a time. They're the constraints. What are some ways we think we could improve on that? Let's have a go. Hun, you've been very quiet today.
We can make it bigger.
Make it bigger. Big giant stethoscope. Okay, we can make it bigger. What else can we do? Let's have a go. Winter, you've been very quiet today as well.
I think we need to designing one more tube, connect to the tube that hear inside thing so it can hear the outside thing.
Okay. Okay, so add extra cups to here around as well as inside. Yeah, sound good to you, Winter? And let's do the concrete listening post. So the concrete listening post is the big giant concrete kind of circle satellite, and it is used to hear planes coming from far away. The constraints are it's very big, it takes a long time to make, you can't really move it around. How do you think we could improve on that design? Katie, Winter?
I think we need to make it smaller, but it can hear.
Make it smaller but still hear it the same, okay. Why do you want to make it smaller?
If making smaller, we can move it easily by hands, not build it. If we make it big, then we have to build it, and it will take a lot of time.
Okay. What's one more thing? So we said that it can't move. What's something that we could do to try help the concrete listening post get around? Yeah, Pumpkin.
Well,
We use wheel and axle to move it.
Yeah, we can use. Yeah, exactly. We can use wheels. We can add wheels to it. Okay. Good job. So what we can do is add wheels. Make it mobile. So good job. There are ways that we can improve. Okay. So the short ear trumpet, we can make the tube longer to let it hear sounds further away. Long ear tube, you can make it lighter, easier to move around, make the trumpet size bigger. That lets us to solve those constraints. Stethoscope, we solved them. And the concrete listening post, we solved them as well. Now, the whole point of doing this is that you can go, right, okay, hold on now. So I'm an engineer. I have decided what my question is. I now know by looking at the criteria and the constraints what I'm looking to do. I now know that I can do some research into nature and to things that have happened before in order to give myself an idea about the best way to make my solution to a problem. So engineers have taken all of these steps. What do you think the next step is? So they've isolated the question, they've looked at the criteria, they've looked at the constraints. They now have done some research into nature and the past, and they have an idea about a way to solve their problem. What's the next thing an engineer will do? They need to actually design their product, right? We haven't spoke about that yet. We said that, okay, they need to do this. Need those like 4 or 5 things. And once they have them done, then they can finally say, hold on, now I have all the information that I need. Now I know pretty much exactly where I'm going to look and what I'm going to do. I'm going to start designing my product. I'm going to start designing my machine. So now that they design their machine, they meet the criteria, they understand the constraints, they've taken things from the past by doing research, they've now said, right, okay, I'm good to go. I've designed my machine and I have made my machine. I've figured out what the solution is. Here is my idea of the solution. Okay, so that's our engineering process to this point. What do you think happens next when you build a machine? Winter.
I think if we build the machine, we need to test it.
Yeah, we got to test it, right? So we've gone through all of this work and we've now decided, okay, right, I think I'm ready. I think I'm good to go. I think my machine can do it. I think I'm ready to solve this problem. So the only way you're going to know is if you're going to test it. Before I go in and talk about it, can anyone tell me why do they think testing is so important? Thailand B. Trixie, why is testing important?
Because add some improvement.
Yeah, so yeah, you're pretty much right. I'm gonna take that. I'm gonna say that's that's about 50% of the right answer. There's another little bit that we need to add as well. Pumpkin, what do you think? Why do we need to test it?
We need to test it to check if it's working well.
Yeah, exactly. So as you I'm going to take both what you have said and what Trixie said because you're two sides of the perfect answer there. Why you test things is, one, as Pumpkin says, you got to make sure it works, right? What's the point of having something that doesn't work? What's the point? You know, imagine you buy a car and the car doesn't move. Oh yeah, I've just bought a really big paperweight. I bought a statue of a car. Great stuff. And as Trixie said, you need to figure out how to make it better as well. What are the improvements? Remember that when you have built something, you're only going to be able to guess what the constraints are, right? Imagine, and this is an experiment we could try to do in class when we get back to class. Please, let's get back to class. Is we can build a machine similar to we tried to build with the simple machines to pop the balloon, right? Remember, you had to build something to pop the balloon. Now, what happened was some of you could not pop the balloon. What would you do in that situation? You go, okay, hold on. Well, look, I've got a design. I'm pretty sure this design is going to work, but it's not working. What can I do? I'll have a look at each of the parts of the design and say, okay, hold on. That's where the problem is. So, as Pumpkin said, it is to figure out if it works well. And as Trixie said, it's to figure out where the improvements can be. So if something does not work as well as you want it to, you're going to stop and you're going to make improvements. And that's the whole point of testing. And that's why testing is so, so important. Everything these days is tested. Everything. It surprises me every time I hear about the amount of testing that things go through. For example, headphones. They go through, I think it's about 15 to 25 different types of tests that you have to go through in order to see if headphones are up to standard. The whole point is that at some point, someone decided that we need to test them. And so what we're going to do is I'm going to show you some testing devices. So testing is the process of evaluating a system to make sure it meets all necessary requirements. Okay, so the whole point of testing is, as I said, to make sure it meets the criteria. Okay, you test to make sure that the criteria actually works, or the machine is working towards the criteria. This is what we do as engineers. We make sure that what we've done is actually meeting the criteria of what we're expected to meet. Okay, so if you test and you do not meet criteria, well then you did it bad. You got to do it again. Here's like an example of just some like product testing. You do the concept testing, which is just the idea. Okay, so you give an idea to a lot of people and you see what they think. The prototype, so you actually build the machine after you've got what people think, and then you get it to work. So you test then again. The usability testing, well, hold on, we've just done a prototype test to see if it works. Now we're going to actually get to see if it can work with people. So once that's done, we then do functional testing. Okay, so one, people like the idea. We've tested the idea works. People are able to use the idea. Now we're going to be able to use the idea and see if it actually works in a functional way. Okay, that's good. So we'd see if it works for what it's actually designed to do. And then when it's done, we get valuable people in, the MVP, to test the product to see if it works again. So this is that's a very, very simple testing life cycle. In between each one of these sections, you could have 40 to 50 individual tests on any particular product. Imagine your prototype doesn't work. Imagine you have to do it again and again and again and again. So once you've got the prototype actually working, you then need to see if people can actually use it. And then you need to see it again and again and again and again and again and again and again. So as you can see, testing is a very long process, but it's worth it. Imagine cars. Imagine you're in a car and your car is not safety tested and you get hit by a tiny, 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 tiny little rock. And the little rock hits your car and your car explodes. Let me ask this question. Why do you think we test you? Why do you think schools test students? Pro, why do you think we give students tests?
To know how the student.
To know how the student is doing in class, So that's a phrase to say if the student is doing well or not, okay? Han, what do you think?
I think that to see how can the student last month can do and where can the teacher help them in the next month.
Yeah, exactly. So it comes back to that word, as Trixie said, for the reason for testing, improving. And something that we looked at as well as improving. So you're seeing, again, there's a pattern there, okay? It's always about improvement. It's always about making things better and improving things as best as we possibly can. So we test students in order to help them improve. We test machines and engineered solutions to make them get better as well. Okay, that's what I really need you to understand, is that testing is about making things better. Research allows us to find things that makes us better as well. So I'm aware that our time is going to be up, okay? So, okay, now yeah, your homework, sorry. I'm going to send you another quizzes for your homework. Everyone have a good weekend. I hope to see you again on Monday. If not, I'll see you here. Good luck, bye-bye.